Today we're going to be graphing sine curves. Sine curves and cosine curves, they look exactly the same. So once you graph them, they look identical. The only difference between sine curves and cosine curves is the start. They start a little bit differently, but then if you were to graph the whole thing and back up, they would look exactly the same. Okay, so I'm going to show you guys how to graph sine curves today, and then at the end of today we'll talk about what we want to do next. All right, so from the unit circle, we're going to pick some points so that we can graph our sine curve, all right? And we're going to pick points in a lazy way. We're going to pick the points that are the easiest to graph, okay? So somebody remind me, if I am looking for sine, am I looking at x coordinates or y coordinates? I'm looking at y coordinates. So when I graph these, the points that I want to graph, if I'm looking at my y coordinates, is I'm plugging in my radians. So I'm plugging in 0, I'm plugging in pi 6, I'm plugging in pi fourths, I'm plugging in pi thirds. Those are the things I'm plugging in. And then the things that I'm getting out of it is sine of 0, sine of pi 6, sine of pi fourths. The things I'm getting out is the y coordinate. So the things that are going to be the easiest to graph would be like 0 is easy to graph, 1/2 is easy to graph, root 2 over 2 is not easy to graph. I don't want to graph that one. Does that make sense? That's hard to graph. Root 3 over 2, that's hard to graph. I don't want to graph that one. Positive 1, I'm okay with graphing that one. That one's pretty easy to graph. Positive root 3 over 2, I don't want to graph that one. Root 2 over 2, I don't want to graph that one. 1/2, that would be fine. 0, I'm okay with graphing that one. Negative 1/2, that's fine. Negative root 2 over 2, I don't want to graph that. Does that make sense? So I'm going to choose points specifically based on what is going to be easy to graph and what is not going to be easy to graph. Does that make sense? Okay, so I'm going to start by plugging in 0 for 0 radians. So I'm plugging in my thetas here, plugging in the radian measure. And when I plug in 0 radians, I get out 0 for sine. The point 0, 0 is going to be really easy to graph, okay? 0, 0 is easy to graph. All right? Now, while it's going to be easy to graph the output of 1/2, graphing pi 6 is kind of hard to graph. Graphing 1/6 of something is kind of hard to graph. Does that make sense? Okay, it might be a little bit easier to graph if I had 0 radians and pi radians, and then I cut it in half and did pi halves. Because then, like, no matter how many boxes I used, I can always cut that number of boxes in half. It might be hard to cut it into 6, but it'll be pretty easy to cut it into half. I'm used to cutting things in half. Does that make sense? So over here, I'm going to skip this one, even though 1/2 is pretty easy to graph, because graphing the pi halves is still going to be pretty easy, and then graphing 1 is going to be pretty easy. So the next one I'm going to graph is my input of pi halves and my output of 1. So I'm still looking at my y coordinates because I'm still doing a sine graph. So I'm inputting a radian measure of pi halves, I'm outputting 1. So input pi halves, output 1. Okay? The next one is pi, input pi, and then sine of pi is 0. Next one is 3 pi halves. That'd be pretty easy to graph if I was doing like 0 to pi and then cut that in half to get pi halves. Then I could do pi to 2 pi, cut that in half to get 1.5 pi, right? That's going to be pretty easy to do. So 3 pi halves is what I plug in. Sine of that is -1. That's not going to be too bad to graph. So 3 pi halves, -1. And then I can make my complete circle. I can go all the way back to the beginning, plug in 2 pi, get an output of 0. Now from there, I would just go around the circle again and I would be getting coterminal angles. So 2 pi after that, I would have 2.5 pi for 1, 3 pi for 0, 3.5 pi for -1, 4 pi for 0. 4.5 pi for 1, 5 pi for 0, 5.5 pi for -1, 6 pi for 0. And now I would just be getting all my coterminal angles. Does that make sense? I would just keep going around the circle, getting the same points over and over again, but I would be getting them with coterminal angles if I wanted to go further. Make sense? Okay, so here's how I'm going to draw it. I'm going to take my marker, and typically if I don't have any transformations on my graph, I like to put my x-axis right in the middle. So I'm going to go ahead and do that. And then I like to do the same with my y-axis too, and I don't remember where the middle is on this notes, so I'm folding my paper to find it. There's the middle. Okay, so I'm just using my marker to mark the x-axis and the y-axis. You'll see later why I'm doing that. For the first couple problems, it doesn't make a difference, but later on it does. And then what I'm going to do is I'm going to count 1, 2, 3, 4 boxes and put a pi. 1, 2, 3, 4 boxes and put a 2 pi. So we know if I counted 4 boxes and put a pi, then halfway would be half of that, right? 2 boxes would be pi halves. 2 boxes here would be 3 pi halves. Okay. And then I'll just go ahead and say on the y-axis that up 2 boxes, I'll say that's 1. Down 2 boxes, I'll say that's -1. Okay, so I want to show you how sine is graphed, because it does the same thing over and over. You guys saw that when I looked at the coterminal angles, it just started to repeat the pattern, right? We got to 2 pi, 2 pi was at 0, and then 2.5 pi was at 1, and then 3 pi was at 0, and then 3.5 pi was at -1, and then 4 pi was at 0, and then 4.5 pi was at 1. You guys can see it's just repeating the same points as I go around the circle. So what happens is we do the first full circle and we get kind of unique points, and then after that we just repeat the pattern over and over and over and over again. So then it starts to look like a cycle. So what happens is we start with 0, 0, and we end with 2 pi 0. So I start with 0, 0, and I end with 2 pi 0. And I actually hit pi 0 in the middle.
So is pi 0 the radius? Like, if you're drawing a circle, would half of the meeting would it be the radius?
Not the radius. I'll show you the radius in a second. Okay. So we start at 0, 0, we end at 2 pi. Now this 2 pi is called the period of the graph. The period of the graph is how long it takes you to go around the full circle. So it took us 2 pi to get around the full circle, okay? And that can change if, when they write the equation, they put a number in front of x. So if it just says y equals sine x, then the period of the graph is going to be 2 pi. But if they put like a 3 in front of the x, it's going to change the period of the graph. If they put a 1/2 in front of the x, or if they say like x divided by 2, that's going to change the period of the graph. Okay, so normal graphs will say you go around the circle in 2 pi. 2 pi is a full circle, but they can change that. So the period of the graph is how long it takes you to do a full pattern. All right, so we did a dot at the beginning of the graph, a dot at the end of the graph, a dot in the middle of the graph. Everyone comfortable with that so far? Yep. Now, between the first 2 points, it goes up to +1 at pi halves. So right in the middle of the first 2 points, it goes up to 1. And then right in the middle of the second 2 points, it goes down to -1. And what happens is these actually look like U shapes. So it's not V shapes. We're not making like a chevron pattern. These are U-shaped graphs. So that's what a sine graph looks like. And then the pattern starts over again. So then from 2 pi, we would go 1, 2, 3, 4. There's 3 pi. 1, 2, 3, 4. There's 4 pi. So we'd say a dot at the beginning, a dot at the end, a dot in the middle. And we would say between the first 2, it goes up to 1. Between the second 2, it goes down to -1. And then we would have this as kind of a U-shaped graph. And this is a U-shaped graph. And we can do it in the other direction as well. So 1, 2, 3, 4, there's -pi. 1, 2, 3, 4, there's -2 pi. So we would have a dot in the beginning, dot at the end, dot in the middle. Between the first 2 points, we would go up to 1. Between the second 2 points, we go down to -1. And we've got our U shape and our U shape. So that's what a sine graph looks like. And that's actually what a cosine graph looks like as well. They both look the same. They just go up and down, up and down, up and down. The only difference is a cosine graph starts at different points. So they start a little bit different, but if I was to put a cosine graph on a grid, it would look like this. All right, now, Safa, this is going to answer your question. The amplitude for us is kind of like the vertical stretch, all right? So I'm going to grab my marker. This right here, from the middle to the top of the graph, this is the amplitude. From the middle to the bottom of the graph, this is the amplitude. So a normal amplitude is 1. That is normal. So this equation did not have any number in the front that showed us like a vertical stretch or a vertical compression. So it had an amplitude of 1. Quentin, are you looking for something? You guys see a do-rag? Anybody? He sits where Talia is sitting. Is there one over here anywhere? No. Sorry, Quentin. All right, so an amplitude of 1 is normal. So if it goes from the middle, if it goes up 1 or if it goes down 1, that's normal. If there's another number in the front, like it says 2 in the front or -3 in the front, then that would tell you that it has an amplitude that's different than normal. So it could go from the middle, it could go up 2, it could go down 3. That would be different than normal. Amplitude just tells you how far it goes from the middle, so the amplitude is always positive. Even if the number in the front is negative, the amplitude will still be positive because the amplitude just says this is how far it goes from the middle. If there's a negative number in the front, it tells you that the graph goes down first and then it goes up. So these graphs usually go up to +1, down to -1. But if there's a negative in front of the equation, then they would go down to -1, up to +1. They would just switch. Okay, so we'll practice some of those as we practice. All right, for the domain, we've got our x's. How far to the left and to the right does this graph go? Forever, right? Forever left, forever right. So we're going to say the domain is -infinity to +infinity. All right? And then how about the range? How about the y values? How far down and how far up does this graph go? -1 to 1. And should I use parentheses or brackets? Can I put my finger on -1 and 1 and it's actually part of the graph? Yeah. So those are definitely brackets. -1 is right here. It's actually a point. It's included. +1 is right there. Those are actual points. Those are on the graph. So brackets for sure. Okay, so we're going to write down some transformations for the sine graph. So we're going to write y equals a times sine b times x minus h plus k. And a lot of these are going to look really familiar to you guys, all right? So the h value is how far to the left or to the right the graph moves, to the left or to the right. And in Math 3, we actually don't shift our graphs to the left or right. We don't do that. That's something they do in Math 4 and in Pre-Cal. But if you had a positive, you would move it to the left. If you had a negative, you would move it to the right. So that's normal. That's what we've learned before. If you had a number on the end, that would move the graph up or down. A positive moves it up, a negative moves it down. This number on the end also tells you something specific, and I will talk about it more when we get to a problem that has that. It also tells you the midline of the graph. Tells you the midline of the graph. So I'll talk about that more once we get there. Okay. The b value, this one right here, we've never seen this before. This is new. The b value helps you find the period of the graph, okay? The period of the graph is just what it takes to give one complete pattern. So this graph, here's one complete pattern. This graph has a period of 2 pi. There's one complete pattern. Here's another complete pattern from 2 pi to 4 pi, so it has a period of 2 pi. Here's another complete pattern from -2 pi to 0, so that's a period of 2 pi. So the b value can impact the period of the graph. The way that you calculate the period of the graph is you take 2 pi and you divide it by b. So the b value, you don't just take the b value and say, hey, that b value is the period. You don't do that. You take 2 pi, you divide it by b, and whatever the result is, that is the period of the graph. So it helps you with the formula. All right, now for us, we are used to the a value giving us the vertical stretch, the vertical compression, and we're used to it telling us if the graph has been reflected over x. And it still kind of does those things, but we don't call it vertical stretch or compression anymore. Now we call the a value the amplitude. And it's in absolute value symbols because the amplitude is always positive. So like I said, the amplitude is just how far does the curve go from the middle. Does it go up 1 and down 1 from the middle? Then the amplitude is 1. Does it go up 2 and down 2 from the middle? Then the amplitude is 2. If the a value is negative, it is still telling you that the graph has been reflected over x. That hasn't changed. So we no longer call it a vertical stretch or a vertical compression. Now we just call it a change in amplitude. All right. So let's go ahead and try a couple examples. So for this first one, we're taking the previous graph that we did, which was y equals sine x, and we're going to do sine 2x. So the 2 is a number that is in front of the x, which means that the 2 is a b value. So it's not a number in front of the sine, it's not an amplitude change, it's a b value, so it's a period change. So the amplitude for this is still going to be 1. But the period of the graph is no longer going to be 2 pi. The period of this graph is going to be 2 pi divided by b. And so 2 pi divided by 2 is what? pi. Okay, so I'm going to take my marker. Because the amplitude is 1 and the period is pi, it's still fine for me to draw my x and my y axis in the same place I drew them last time. So I'm just going to draw them right in the middle. Sometimes if you have a big amplitude, it can be helpful for you to draw maybe if you have a big amplitude or something and then the graph has been shifted up, then maybe you should draw your x-axis lower or something like that. Sometimes it's helpful to move them. But a lot of times you can put them in the middle and it doesn't really matter. Now, my rule with students to make these easier to draw is to always put your x-axis in groups of 4. So you can do pi for every 4 boxes, 8 boxes, or 12 boxes. 4 boxes, 8 boxes, or 12 boxes. And that's because I'm lazy and it makes it easier to draw. Okay, so what I've learned in the past is that students tend to prefer 4 boxes, but it really doesn't matter. All it's going to do is it's either, if you do 4 boxes, your graph is going to look smaller. If you do 8 boxes or 12 boxes, it makes your graph look more spread out. That's the only thing that it does. Okay, so let's go ahead and do 4 boxes. So I'm going to count 1, 2, 3, 4 and put a pi. 1, 2, 3, 4 and put a 2 pi. And then the amplitude is 1, so I'm going to count 1, 2, and then 1, 2. I'm just going to do the markings the exact same way that I did last time, so you guys can see how this graph is going to change now that the period is pi instead of 2 pi.
Why did it go 2 units up instead of 1 unit?
I did that just because I don't like it when my graph is really short. Yeah, so for me that's personal preference. Okay, so I'm going to follow the same process that I did last time, but I'm going to adjust it because the period of the graph is pi instead of 2 pi. So last time we put a dot at the beginning of the graph, and we put a dot at the end of the graph. The end of the graph last time was 2 pi, but this time it's just pi. So I've got a dot at the beginning, I've got a dot at the end. Then we had to put a dot in the middle. So a dot at the beginning, a dot at the end, a dot in the middle. You guys remember doing that? Okay. Then between the first 2 points, we had to go up to 1 and put a dot there. And between the second 2 points, we had to put a dot down at -1. So at this point, does this look similar to the graph we did last time, but it's half as wide? Looks the same. Okay, so I'm going to do this. I've got the U right here. There's my U shape. Here's my U shape. And then I'm going to do the pattern again. I've got my dot at the beginning. There's my dot at the end. My dot in the middle. Between the first 2, I'm going to go up to 1. Between the second 2, I'm going to go down to -1. And I've got my little U shape and my U shape. Go ahead and draw another one. 1, 2, 3, 4. Put a dot at the beginning, a dot at the end, a dot in the middle. Between the first 2, I'm going to go up to 1. Between the second 2, I'm going to go down to -1. Got my U shape. Got my U shape. All right, I'm all done. All right, how do you guys feel? Good? No? What part was weird? Got narrow. So what it did is we took the 2 pi, and this, remember how like if you had the inside of the graph, if it had a plus, it actually moved to the left? If it had a minus, it actually moved to the right? So this one, it has a 2, which makes you think that it would double something, but it does the opposite, cuts it in half. So you'd think that it would be twice as wide, but instead it's half as wide. So what we did is it's kind of like an accordion. We took something that was this wide and we squished it together. We made it half as wide. Okay, so this is what we've got. Now let's do the domain. How far to the left and to the right does it go? Yeah, forever to the left, forever to the right. All right, for the range, how far up and down does it go? -1 to +1. Okay. All right, let's go ahead and flip to the next side. Okay, this problem is similar, but this time we have a 3 for the b value, and they're telling us to flip the graph over the x-axis. Okay, so the amplitude is still 1. We're going to reflect it over the x-axis, so we're going to change. It's not going to go up first, it's going to go down first, but it still has an amplitude of 1. The period of the graph this time is going to be 2 pi divided by 3, so it's just 2 pi thirds. The graph is going to be 2 pi thirds wide this time. Okay, so I'm going to go ahead and draw my lines. Okay, do you guys want to do 4 boxes, 8 boxes, or 12 boxes? 4, marvelous. Okay, so we're going to do 1, 2, 3, 4, and we're going to put 2 pi thirds. So whatever the period of my graph is, that's how I count my 4 boxes, because I know when I draw this, I'm going to take the period of the graph and I'm going to cut it in half and then cut it in half again. So whatever the period of the graph is, that's how I want to label it, because that's the easiest way to do this. Okay, so I did 2 pi thirds, and then I'll do 1, 2, 3, 4. If I do 2 pi thirds and another 2 pi thirds, how many thirds is that? 2 pi thirds and another 2 pi thirds. That's 4 pi thirds. Okay. All right. Amplitude of 1, so I'm going to put my markings the same over here. Okay. So we're going to do the same that we did last time. We're going to start at 0. We're going to end at 0. We're going to hit 0 in the middle. Start at 0, end at 0, hit 0 in the middle. Now the normal thing to do between the first 2 points is to go up to 1. That's normal. But this graph isn't normal, this graph is negative. So what do we do between the first 2 points? We're going to go down. Down to -1. Okay? Now what's normal is between the second 2 points we would go down to -1, but this graph is not normal. We're going to go up to +1 instead. This graph is backwards. All right, I got my U shape. I got my U shape. And then I do it again. I got my beginning, my end, my middle. Between the first 2 points, I dip down to -1. Between my second 2 points, I dip up to +1. Okay, 2 pi thirds, 4 pi thirds, what would be next? Yeah, 6 pi thirds, and 6 divided by 3 is 2, so 2 pi is the next one. So I've got the beginning, I've got the end, I've got the middle. Between the first 2, I dip down to -1. Between the second 2, I go up to +1. Now, what I say is you need to draw the pattern. So here is one period of the graph, right? There's another one. There's a third one. You need to draw it at least twice to show me you understand the pattern. You can draw it once, but you can draw it again. Okay, draw it at least twice to show me you understand the pattern. Okay, for example 3, we're going to rewrite this because I want to know not what the number is underneath the x, but I want to know what the coefficient of the x is, and some students get confused when it's written this way. So this is the exact same thing as y equals -2 sine times sine of 1/2 x with a +1 on the end. So x divided by 2 is the same thing as taking 1/2 of x. So that x has a coefficient of 1/2. Okay, what is our amplitude for number 3? What is the amplitude? 2. We have an amplitude of 2. For the period, we're going to do 2 pi divided by the b value, which is 1/2. How do we divide by a fraction? Keep it, change it, flip it. So I'm going to keep the 2 pi, change it to a multiplication problem, flip the bottom. So 2 pi times 2/1. What is 2 pi times 2/1? 4 pi. Okay. Okay. And then we got to be careful because this one has also been shifted up 1. We haven't had that happen yet. All right, so here is what we're going to do. First, we have to decide how many boxes we want to use for the period of 4 pi. So for 4 pi, do you guys want to use 4 boxes, 8 boxes, or 12 boxes? We're just going to stick with 4? 1, 2, 3, 4, 4 pi. 1, 2, 3, 4, 8 pi. 1, 2, 3, 4, 12 pi. Okay. And we can always go in the negative direction too. 1, 2, 3, 4, 4 pi. 1, 2, 3, 4, 8 pi. Okay. Now we have to have room to shift the entire graph up 1, but still have an amplitude of 2. So it has to be able to go up 2 and down 2, but then you have to be able to take the whole graph and move it up 1 box. So we're going to have to count 1, 2, 3, 4. 1, 2, 3, 4. We're going to have to do that so we have enough room for this graph. And then what I want us to do is we're going to go back to some of these other problems now that we've drawn a few of them. And I want to talk a little bit about the midline. So we already know what the amplitude is. We've done that a few times here. So we know for this graph it has an amplitude of 1. It goes up 1 from the middle, down 1 from the middle. This has an amplitude of 1. It goes up 1 from the middle, down 1 from the middle. The midline is the middle. It's the line in the middle. So here, and so far this is all that we've had, the x-axis has been the midline for every graph that we've done so far. So the midline was the x-axis on this one. On this one, the x-axis was the midline. On this one, the x-axis was the midline. And now for the first time, we're going to have a midline that is different than the x-axis. So what we're going to do is we're going to you can take your marker or your pencil, whatever your preference is fine. I'm going to take my marker and I'm going to draw a dotted line where my midline is going to be. So my midline is up 1, so I'm going to draw a dotted line up 1. And that means that this time when I draw my first points, I'm going to draw them on the midline instead of on the x-axis, because that's where the middle of my graph is. So I'm going to start by putting a dot on 0. So it starts at 0, it ends at 4 pi, and then of course I've got the middle. Now, in the very front of the equation, I have a negative sign, and I've got a 2. So normally, between the first 2 points, I would go up 1, but instead, I've got a negative graph, and I have an amplitude of 2. So what should I do instead of going up 1? I should go down, and I should go down not just 1 box, but I should go down the equivalent of 2 boxes, or the equivalent of 2 numbers. So between the first 2, I'm going to go down 1, 2. And between the second 2 points, normally I would have gone down the equivalent of 1, but this time I'm going to go up because I have a negative in front of my equation, and I'm not going to go up the equivalent of 1, I'm going to go up the equivalent of 2 because I have an amplitude of 2 this time. So you always have to be really careful to see, when I did my boxes, did I do it this time where I did 1 box equals 1 number, or did I do it like last time where I said each box equaled half a number, so this was half and then 1? And so to do up 1 box, down 1 box, or up 1, down 1, I had to actually do 2 boxes instead of just 1. So just be careful of that. When students make mistakes on these, that's usually what the mistake is. That's what I've noticed. And then I'm going to do the pattern again to show that I understand it. So start at the beginning. I'm going to end at 8 pi. I've got my dot in the middle. Between the first 2 points, I'm going to go down 2. Between my second 2 points, I'm going to go up 2. Beginning at 8 pi, ending at 12 pi, putting a dot in the middle. Between my first 2, I go down 2. Between my second 2, I go up 2. So for this one, the midline isn't the x-axis, it's the line y equals 1. All right, what is the domain? Yeah, this still goes forever to the left, forever to the right. Will the domain ever be something different? No, the domain is always going to be the same. It's always going to go forever left, forever right for a sine curve. What's the range for this graph? Yeah, -1 to +3. So the range on these can definitely change. And then brackets, we can actually touch those numbers. Okay, for the next one, we're going to scribble out the equation and do a different equation. Okay, we're going to do y equals 3 sine pi x plus 1. Okay, so based on the equation, what is the amplitude for this graph? 3. We got a 3 in the front of the equation, so the amplitude for this graph is 3. Okay, what is the period for this graph? 2 pi over pi. 2 pi divided by pi, which is 2. So it is possible for the period of the graph to lose the pi if your b value has a pi in it. That's possible, it can happen, and it's not all that uncommon either. It happens pretty often. Okay, so the amplitude of the graph is 3, the period of the pi is 2. I'm going to go ahead and draw my x and my y axis. You guys want 4 boxes, 8 boxes, or 12 boxes? 4? 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. Now for this one, if our amplitude is 3 and we're going to shift the graph up 1, that means we're going to have to go by 1s on our boxes. That's the only way we're going to make it fit. So I'm going to make sure I go by 1s. Now with these, because each of the graphs have periods that are like drastically different, have amplitudes that would make them fit different ways, you have to label your axes. This is like the one time, like on other graphs this whole semester, you didn't have to label them. You could just assume they went by 1s. With this graph, you cannot. You have to label these. In a testing situation, if you don't label these, I have no idea how to grade it. Okay, so you have to label them. Okay, so I'm going to go up 1 and put my dotted line. For my midline. All right, and what am I going to do? I think I might have, hold on, did I put them here? I might have put the, I think I put the extra notes back there already on the table. Okay, what do I do from here? So I start at 0, end at 2. What else do I do? Put a dot in the middle, okay. And then between the first 2 points, what should I do? Go up 2? Go up 3, because my amplitude is 3. So I'm going to go up 3 boxes, okay? And then between my second 2 points, what do I do? Go down 3. Okay. Okay. Now what do I do?
What's the end?
4. Okay, put a dot at the end at 4. And then the middle. Okay, between the first 2 up 3, between the second 2 down 3. Okay. And then what do I do? Okay. And what's my domain? Okay. And then what's my range? -2 to 4. Okay. All right. How do we feel about doing these ones? Reasonable? Okay. The practice worksheet that I have for you guys has, it's got 9 problems on there. Let's start. What time is it? My clock is gone. It was gone yesterday? Okay. Okay. Let's start with the first 4 and just see how far we get. Okay?